In today's lesson, we are focusing on equivalent fractions. So the first thing we're going to look at is the multiplicative identity property. And what that means is that when you multiply any number by 1, it does not change the value of the number. So we know that to be true. If I do 5 times 1, my answer is going to be 5. 10 times 1, my answer is still 10. I'm multiplying, but I'm not changing the value of that number that I started with. So for here, I put some examples, 1, and I want us to just come up with some examples for 1 that are a fraction. So for example, I would have 3/3. It's out of 3 pieces, and I have all 3. That is equal to 1. I could do 10 over 10. I could even do like 250 over 250 and 5 over 5. So you can really come up with any example as long as the top number and the bottom number, your numerator and denominator, are the same. All of those fractions are going to be equal to 1. So when we multiply by a 3/3 or a 10/10, we're not changing the number. It's still going to be the same value, but it is going to look different. And I'll show you what I mean. Okay, so I have some problems right here for you in blue. So I have 5/6, and we're multiplying by 2 halves here. And I'm going to go ahead and put my green little 1. That really means 5/6 times 1 equals a number. And so it's going to still equal 5/6. It is still equivalent. It is going to look different though. So I'm going to multiply the top, 5 times 2, that equals 10. And the bottom, 6 times 2, that equals 12. So now 5/6 and 10/12, they are equivalent, meaning they are equal. They are of the same value, but they do have different numerators and denominators. One more time, I'll show you again. I have 3/4 and I'm multiplying by 5/5. 5/5 is really equal to 1. And when we multiply by 1, it's going to hold its value. So 3 times 5 is 15, and 4 times 5 is 20. So 3/4 and 15/20, they are equivalent fractions because I multiplied it by 1. So though the numerator and denominator are different, they are still equivalent. So I will just show you quickly what happens when we do our model of this with multiplication like we've been practicing. So I'm going to do 2/3. I'm going to kind of draw that out here, and then I'm going to shade in 2/3. So here's 1. And then here's 2. So right now, this is the size of 2/3. And now I'm going to multiply it by 4/4. So going the other way, I'm going to draw, remember, 3 lines. So I have my 4 pieces. And I am going to shade 4 of them, all 4 of them. Let me grab my highlighter here. So 1, 2, 3, and finally 4. So when I'm looking at this problem here, 2/3 is going to be the same as 1, 2, 3, 4, 5, 6, 7, 8. 8, and how many of them am I out of? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And so you can also see 2 times 4 is 8, 3 times 4 is 12, and they are equivalent fractions. I'm going to show you over here the sizing of it so that it can also make a little bit more sense. So for example here, I'm going to just kind of show you what I have written. So I have my first fraction right here, and I'm going to say that that is 1/2. 1/2. If I were to multiply 1/2 times 3/3 or 3/3, remember that is really equal to 1. If I multiply it by 3/3, my answer is 3/6. So I have this one, this other black down here, and I'm going to shade in 3. And you can see I'm out of sixths. And what I want you to see is I took that 1/2 and I multiplied it by 1. So now my numerator and my denominator are different numbers, but if I were to move them around, I would be able to see that they are going to be, if I put them on top of each other, equivalent. They are equal. They are the same. So I start off with 1/2 right here, multiplied it by 3/3, which is really 1, and I get 3/6, which here's my answer. But just so you can see, though the numerator and the denominator are different numbers, they are equal. They are the exact same. So just so you can kind of see that. And I'm going to zoom back out. And lastly, we just have another problem here, original fraction. So I'm going to say that I'm going to start with 2/3. That's my original fraction. And I need a denominator of 18, meaning I want that denominator to be 18. So what did I multiply by? So here's my 2/3, and I know it's going to equal 18. So I'm thinking, okay, 3 times what gives me 18? And I multiplied by 6. So what I'm really doing here, when I multiply the bottom by 6, I'm also multiplying by the top. We know how that works from previous videos. 2 times 6, that equals 12. So what did I multiply by? My form of 1 was 6/6. My equivalent fraction ends up becoming 12/18. So just so you can see. So that's kind of like working backwards. It's almost like a challenge problem here. All right, here's your lesson practice. So you're going to create equivalent fractions. So I start out with a fraction. You can put whatever form of 1, 2/2, 5/5, 10/10. And then what does your equivalent fraction equal?